Okay everyone, let's start the experiment. I have my setup ready. I have my stock solution of sodium hydroxide labeled, my stock solution of crystal violet labeled. I have my reaction beaker. I have really 3 test tubes is all I need for this work. One of them is for the known solution and these are labeled. This is the known crystal violet stock solution. The other one is the hydroxide solution and the crystal violet, that's the stock solution. The known stock solution is diluted, so you're only going to use it once for determination of the Beer's laws constant, and you're not going to use that again. So the procedures call for making that first. So I'm following the procedure. It asks for pouring in 3 milliliters of the stock solution of crystal violet into a graduated cylinder, and we're going to transfer this to our label test tube. So I'm going to do this. So I'll measure 3 milliliter and pour that into the known. And when you do this, you want to make sure you don't tap, you just gently touch the lip of the graduated cylinder, and there it is, the 3 milliliters transferred. And now you wanted to rinse this and add 7 milliliters of water to it. So altogether we have 10 milliliters. So let's add the 7 milliliters of water. There is my water, and then I'm transferring it over here. Now this solution should be mixed, so I have a piece of parafilm, so stretch that over the test tube, and now you're sealing it, and go ahead and hold this with your thumb and invert a few times. So I'm going to set this aside because I'll use this later with my spectrophotometer. So let's go ahead and talk about the reaction mixtures. So if you follow the procedure, there is actually a table that shows you the different experiments. So for example, for the first experiment, that's the one we're going to do first, you need to have 15 milliliters of crystal violet stock solution plus 10 ml of water, and that's a total of 25. And then you're going to have a hydroxide solution prepared as 20 milliliter of hydroxide plus 5 ml of water, that's a total of 25 ml. And each solution, the crystal violet solution that's diluted, it goes into the crystal violet test tube. The hydroxide diluted solution goes into the hydroxide test tube. These test tubes are large enough that they can hold 25 milliliters. So let's go ahead and prepare our experiment 1. So I'm going to just use my 25 ml graduated cylinder, and let's work with the crystal violet. So I need 15 milliliters of that. So I'm just going to transfer 15 milliliters into this. You may want to use your eyedroppers to make sure that you're adding exactly 15 according to the precision of your graduated cylinder. So we add that to our crystal violet test tube. And 10 milliliters of water. So rinse your graduated cylinder once or twice and add 10 milliliters of water. And I could have used a 25 milliliter graduated cylinder for this, and so let's go ahead and add that. And again, use a piece of parafilm and cover up the top of the test tube by stretching the plastic over the top. Make sure it's stretched in all directions, and hold the top of it with your thumb and invert 4 or 5 times to mix thoroughly. So this is my experiment 1's diluted stock solution of diluted crystal violet solution. And now let's work on the hydroxide. So I'm going to rinse this, and we're going to need 20 milliliters of hydroxide with 5 milliliters of water. All this is for experiment 1. So 20 milliliters of sodium hydroxide. Same procedure. Use your eyedropper to bring the volume to 20. There it is. And add that to your label test tube. And now you want to add 5 milliliters of water to that. Rinse your graduated cylinder. And use the same graduated cylinder and add 5 milliliters of water. So go ahead and cover up the top again, just like before. Stretch the paraffin over the top. And hold the top with your thumb and invert, mix by inverting 4 or 5 times. That's good. Now you have the 2 solutions ready for your experiment 1. So we're going to transfer these solutions, including my reaction beaker. It goes into your 400 milliliter beaker. So this is just to make sure that the temperature of these solutions are all the same as the contents here. So it's roughly my thermometer shows 14 point, pretty close to 14.0. So we're going to record that temperature too somewhere. But let's go ahead and follow the procedure. So I'm actually following this. I followed step 8. And now we're ready. Just leave everything in your beaker and let's work with our spectrophotometer. So we need to walk up to the spectrophotometer, turn it on, and wait for like 5 to 10 minutes for the machine to warm up. And you have your 3 cuvettes here, and you want to go ahead and just adjust the video camera a little better so you can see the cuvettes. So now you want to follow this procedure. So I'm going to go to your scan, and you want to take one of your cuvettes and fill it with a little bit of your known solution, but make sure that you condition this a couple times. So I'm going to fill it once and dump it into your waste beaker, and fill it a second time and put that in the cuvette holder, and make sure you insert this correctly. There's an arrow in my cuvette, and this arrow should be in the path of light. And before I insert it, I want to make sure that the 2 sides that light goes through are wiped clean. So my arrow is in this direction, so insert that into the cuvette holder. And now we need to do a scan. The scan is so that we can figure out what wavelength to set my machine to. So you want to see what the spectrophotometer shows in terms of the absorbance spectrum of crystal violet. And now my peak of the wavelength, you can see that the peak of the wavelength is right in this position. It's kind of small, it's hard to see, but I'm going to move my cursor and go right to that peak. My absorbance is 0.994 at that peak, so don't record anything. And your wavelength is 595. You do want to record the wavelength. So I'm going to put my lambda is 595 nanometer. So now you want to go back to your main menu and go to a live display. So notice the wavelength is set at 595 nanometers. Remove your crystal violet known solution and place a blank in the spectrophotometer. Again, make sure that it's inserted in the correct way. And so the blank should have an absorbance of 0, and you can see it doesn't right now because we haven't zeroed the machine. So press the 0 and let's wait till it reads 0. You don't have to close the lid in these machines, so they can be sort of left open. So let's wait. Okay, there you go. Absorbance is 0. So now you're going to measure the absorbance of your solution. So there is my absorbance, there's my solution, and insert it the same way that you did before. And now you want to record this absorbance. So my absorbance is 0.906. Absorbance doesn't have units, and that's it. So you want to take this out now. So at this point, you don't want to change anything about your spectrophotometer. I do want to check my 0 one more time, but you don't have to worry about it now. So you've already completed step 9, and we already read the absorbance of my known solution as well. Now we're ready to do our kinetic experiment. So you want to go ahead and follow the procedure. So this is the idea. You want to read step 11 very carefully. And the idea is that you're going to take out the solutions, the two solutions here, one crystal violet and one sodium hydroxide. And you're going to pour them into this reaction beaker. And when you pour it into the beaker, you want to swirl the contents for like a couple seconds, not too long. And you want to take this cuvette that's empty and fill it with the solution. And of course I want to condition it once and fill it the second time, and then start your absorbance reading. So get your data tables ready. I have my data tables in my lab notebook. So this is experiment 1 that you're performing now. And there are 2 experiments on this page, and both of these experiments are at room temperature. Experiment 1, experiment 2. I've only prepared the contents of experiment 1, and where I'm going to write up the information. I guess I should be writing down 595 nanometer here. I wrote it down in a separate page. And the rest of the stuff I can wait the cuvette temperature, and that's measured later. So I'm going to, the idea is once the reaction proceeds, I'm going to write the absorbance down for every 15 seconds. So you want to start at 0.5 minute time. I have a timer, and then 0.75, 1 minute, 1.25. So it's every 15 seconds. You want to measure your absorbance because the reaction proceeds and the absorbance should drop. And we'll calculate the concentration later. So let's go ahead and do this. So I'm going to do this step here. So take this and dry the outside of your test tube. Transfer your crystal violet. The order doesn't matter. So you want to transfer the Crystal Violet first, or the other one first, doesn't matter. And make sure that the bottom of your test tube is dry, because you don't want any water dripping from the outside into your reaction beaker. So now I want to do the same with the other one. So I take the sodium hydroxide, dry the test tube, and then transfer. So here you are, you don't have to rush. So I took care of the two solutions. So swirl the contents for like maybe a couple seconds, really that's all you need. So now you're going to fill your cuvette once, dump into your waste beaker second times, and make sure that the outside where light goes through is dry and there are no fingerprints. Put that into your spectrophotometer. And I forgot to start my timer, so let's go ahead and do this now. But normally from the time that you mix the contents, you want to start your timer. So I'm a little bit off in my time, but it shouldn't impact anything major. So I started with well, we're going to be measuring our absorbance. Once the timer shows 0.5 minutes, which is 30 seconds. There it is. My absorbance is 0.671 recorded. And now you're going to do this process all the way till 6 minutes. So you want to just measure and keep recording here. So I'm going to read the absorbances for you and record it into your notebook. So the second one is coming up. It's 0.599. That's at 1 minute. And I didn't measure it every 15 seconds, but I'm going to do it from now. But now the next one is 0.559. So I did 1 minute 15 seconds. Now I'm onto 1 minute and 30 seconds. It's 0.528. Maybe I should, I don't know if you can see the timer. So 1 minute 45.499. We're getting ready for 2 minutes. 0.466. Two minutes and 15 seconds, 0.440. 2 minutes and 30 seconds, 0.416. 2 minutes and 45 seconds is 0.393. Approaching 3 minutes. 0.370. Three minutes 15 seconds, 0.350. 3 minutes 30 seconds, 0.329. 3 minutes 45 seconds, 0.309. Four minutes, 0.292. 4 minutes 15 seconds, 0.275. 4 minutes 30 seconds, 0.263. 4 minutes and 45 seconds, 0.247. 5 minutes, 0.234. 5 minutes, 25 seconds. I'm sorry, I missed that. So let's go to 5 minutes and 30 seconds. It's okay if you miss a data point. 0.209. 5 minutes and 45 seconds coming up. 0.193. And on my last reading for experiment 1, 6 minutes coming up. 0.187. So there it is. I am done with this set. I'm just going to show you, I recorded my data, and there is my data. And you want to do the same for experiment 2, and then we need to do our cold run and then my warm run. So, and then of course we need to record the temperature. Now for this experiment, what you do need to do before you complete this run is take your cuvette and measure the temperature of this solution. So this should be pretty constant to room temperature, might be a little different. So I am recording 15.5 degrees Celsius. So that's what I'm recording here. And so with every run, at the end of the run, we measure the temperature using our thermometer. So that's it. I'm going to do the other runs and show you the data for the other runs, and you're ready for the data analysis.